Hey guys, welcome to our channel. We got a lot to get through in this, so I'm going to get started. And this is only part one because I'm pretty sure I have to go through this again, forwards and backwards. All right, so we got Nirvana in Bloom, okay? Now, normally I've been doing this at the same time, but in this case, we're going to make it a two-parter. And the reason for that is it's a lot to get through. All right, you'll understand in a moment. So what we had was sell the kids turned to kids, so the fell off. All right, so we brought the down, and we put the right here. All right, then reap the dark within became reproductive glands. Doesn't rhyme anymore. Spring is here again, reproductive glands. Instead of reap the dark within, it rhymed, you see. But I'm not going to get into that now. We're just going to see how it decodes. So you will have reap changed to reproductive, and so R-E-P fall off of both, and you're left with A from reap. So A comes down, and you're left with R-O-D-U-C-T-I-V-E from reproductive, so that comes down. And the dark fell off, so the dark just straight comes down. There's the dark. We got that. Then you had within changed glands, so the N does cross off, and you're left with W-I-T-H-I and G-L-A-D-S. And we brought that down, whoop, right there. And then you're left with a series of S's totaling 6. So you're left with a total of 7 S's. All right. Here we go. I recognized right away that you had TH, which we've seen before, TH gene, a protein coding gene, right? And this is by the way, a 4.2% variant song, right? So a little bit higher than some of our others. And so that TH could be a coincidence. But EA then was esophageal arteria. The purpose of this, let's see, this is the purpose of this overview is to increase the awareness of clinicians regarding esophageal atresia, tracheosophageal, dang, fistula, and its genetic causes and management. So a genetic disorder was the next thing that we found. All right, yeah, those things are hard to pronounce. So the next thing we found was you had RO next, and RO ends up being preptide sequence of cinnamycin, and it's RO090198. It's a sequence. It belongs to the Duramycin type lantibiotics and contains the unusual amino acids 303-methylathonine. And then there's a whole bunch of stuff that's hard to pronounce. And then it goes on to talk about its structural gene referenced as CINA has been identified on isolated chromosomal DNA of RO90198, producing strain, and then a whole bunch more stuff you can't pronounce. But it's about genetics, guys. All right? And that is a whole lot of stuff that's hard to pronounce. I'm going to provide the links down below. But it's all dealing with genetics, and D stood for deuterium, which we've had before when combined with hydrogen, is used to study proteins. Well, we've already had the protein coding gene. It's one of the stable isotopes of hydrogen. All right. And by the way, H is in there too. And so when you got a quantum computer, you've got hydrogen deuterium. I suppose I should have included that. And it's used to study the dynamics and conformation of proteins. We've had that before. All right, along with this protein coding gene. We're not done with the protein coding genes. UC is a genetic, I believe, ulcerative colitis. It's a disease, inheritance pattern disease. So genetic. What do you know? Genetics. More genetics. And this is a genetic disease. All right. So I told you this was going to be a headache, right? And was it ever? UC also stands for UC chemicals. Why is that significant? Because we oftentimes seem to see them looking up genetics and chemicals in the same search. Why? I don't know. But I don't really know that I like it. So, UC Chemicals is a cloud-based chemical inventory management tool developed with a researcher-centric approach. It allows easy tracking and maintenance of containers using barcoding system, chemical and safety information such as hazard codes and first aid are auto-populated. The application enables users to create chemical networks to easily share chemicals while controlling access. UC Chemicals includes a complementary web application that works in sync with the mobile app. And so, yeah, there you have it. Looking up genetics, and right there with it, chemicals. We've had that before. It's a pattern, right? All right. So then the next thing you end up with is TI, and TI is the MT-TI gene. Imagine that. Another gene. No, that is not the MT. There it is, MT-TI gene. Health conditions related to genetic changes. Chromosomal location. Mitochondrial encoded tRNA isoleucine. Tough stuff to pronounce, guys, but it's a gene. It's another gene. Then you got TI also stands for TI plasmid, which seemed significant when I read about it. Let's take a look at it. It's not the TI plasmid. TI plasmid of Agrobacterium tumefaciens as a tool for genetic engineering in plants. So now we're looking at genetic engineering, albeit plants, but who knows what else they could look at. Genetic engineering is in fact genetic engineering. Let's just say they're looking at genetic engineering. All right. And the next thing you got ends up being a V by itself, and you might think that could be nothing, but no, factor V. Factor V Leadian is the most common genetic risk factor for uh, venous, holy cow, venous thromb, VTE, that occurs in about 5% of the Caucasian population. It's factor V, guys. It's a genetic risk factor for something I can't pronounce that occurs in about 5% of the Caucasian population. And you got another genetics. Imagine that. Then you've got ETH, which we've had before. ETH Zurich, Computational and Statistical Genetics. They're a biology lab, basically. Then you had EDA after that. Yep, EDA. And EDA ended up being EDA gene, a protein coding gene. A protein coding gene, imagine that. Yep, EDA gene, protein coding. So there's another protein coding gene in the same search, right, guys? Then you had RK, which R and K selection. It's a theory. I think it's a theory. Organisms that live in stable environments tend to make few expensive offspring. Organisms that live in unstable environments tend to make many cheap offspring. And imagine that you are many invertebrate organisms that existed. It's a study on, seems to be natural selection. You can read all about it. This is starting to run long, but it deals with genetics. It's a theory on genetics, which leads you to WIT, which ends up being chemical engineering. At which university? Imagine that, because we got chemicals, and now you got chemical engineering. Large-scale industrial processes that convert raw materials into products with higher economic and social value. Chemical engineering and genetic engineering. Imagine that. Are we we done yet? No, we're not. That was the okay. Then you got HIG, which ends up standing for human interferon gene, and it involves genetic engineering. So more genetic engineering, chemical engineering. GLA is gamma lyonic acid, and gamma lyonic acid is an important omega-6 nutrient needed for important bodily functions such as maintenance of hormonal balance and healthy skin structure. So I'll leave that link, and that once again is dealing with basically human DNA, hormonal balance. Fun stuff, guys. These are the things they're looking at. GLA, that's what we just did. DS, dissociator element. And it can break down chromosomes when added to or when it reacts with a activator element. So it causes chromosome breaks, and chromosomes are in all of us. And it again deals with genetics. That's what you got going on. SS is SS genotype. It's a certain genotype. I don't think I need to get into it, but it involves genes. And 3 S's stands for sick sinus syndrome, which is another genetic disorder. So, and you get that twice. And that gets you through that long mess going forwards. Going backwards. Do you think we hit any genetics, guys? Let's find out. SDA, inhibitor of histine and kidneys. I almost thought it said kidneys at first, guys, but that's not. It's not. Oh, there is the genotype, the genetic genotype. Wasn't going to get into. Here you go. Genetics of sick sinus syndrome. Genetics. SSS. So another genetic disorder. Then you had LGI, which ends up being the LGI1 gene, and it is a protein coding gene. All right, it's a protein coding gene along with these other protein coding genes and HD, hydrogen deuteride, which is used to study the dynamics of proteins. It's all coming up, guys. So HT is the HT gene. There is an HT gene. And HT also stands for genetic drift. All right, now we're coming backwards. We're at H. We just did HT. I'm trying to get through these quickly, guys. EVI, then. EVI is the next 3 letters coming back, and that is the EVI1 gene. And the EVI1 gene, let's see, where is the EVI? Well, there's your SDA inhibitor. LGI1 gene provides instructions for making a protein, so another protein coding gene. All right, LGI1. Another protein coding gene, guys. You'll have to forgive me, I'm kind of losing my voice. Um, that's what's going on with all this. My voice is kind of going out, and I apologize for that. But HT gene, HT genetic drift, EV1 gene, then T by itself is T box proteins. They're a family of proteins represented by a T. Right? Then you've got CUD, which ends up standing for carnitine uptake defect, and it's some sort of a defect in newborns, apparently. Um, and you'll be able to read all about it. I will leave the link. Um, and the next thing you have is ORA, and ORA ends up being ORA gene family. It's a V1R ORA gene family in the Japanese grenadier anchovy. Why would that be significant? A number of studies have suggested that olfaction plays an important role in fish migration. Fish use several distinct families of olfactory receptors to detect environmental odorances. And it goes on to list several of their receptors that they have. Now, why would that be significant? Well, we've already had two other genetic engineering hits. One dealt with human genetic engineering, right? Put two and two together and trying to give humans super receptors. And finally, EHT ends up being the EHT gene, guys. It's a gene. It's a new member of the MTG8ETO gene family. So there you have it. More genetics. Genetics all the way through. And that got you forwards and backwards through all the changed letters in Nirvana in Bloom. Once. Now I'm going to do it again because I'm just sure they hit the stock market, and we're going to do a part 2 on this, and it's going to be probably about the money. We'll see. But anyway, that's Nirvana in Bloom Decode Part 1 anyway, for sure. And we'll see if it had to do with money. I haven't done it yet, so I don't really know. I'm just assuming that it does. I could be wrong. I'll let you know if I am. So that's going to be it for this decode, guys. Sorry it ran so long. Sorry about my voice. And thanks for all your thumbs up, thumbs down. Thanks for all your comments, feedback, subscriptions, support. Thanks for putting up with our little dork who's coming on our site and saying dipshit stuff. Excuse my language. And thanks a lot for watching, guys. And for now, you guys have a great rest of your night.